Hello everyone, my name is Alexis Johnson. I am a biomedical engineering student at the University of Memphis with an anticipated graduation date of May 2022. And today we will be speaking about the work I have been able to assist with for the Electrical and Computer Engineering Department, which is using machine learning to predict estrus in sows using infrared imaging with Dr. Aaron Robinson and Master's graduate Tacker Colbert. In this presentation, I will provide an overview of what estrus is, the effects the estrus cycle has on the female pig, and how the temperatures are analyzed, and how all these factors come together to help us predict and determine when a female pig will be in estrus. For our evaluations, the pigs recorded were female with one or more litters. The term for a female pig that has one or more litters of piglets is a sow. In mature sows, estrus normally begins within 3 to 5 days post-weaning. Now you may be wondering what estrus is. Estrus is defined as a period of sexual receptivity and ovulation during which the female will accept the male and is capable of conceiving. Estrus has a more common name that may be more familiar to some of you, which is in heat or standing heat. When a sow is in heat or in estrus, this process generally lasts 40 hours in gilts and 55 hours in sows, but variation among individuals can be substantial, which according to previous literature is from a range of 12 to 84 hours. Now, what are the ways estrus can be either detected or observed? There are many physical changes that the sow experiences leading up to its peak sexual receptivity in estrus. As you can see on this chart, standing estrus begins at the peak estrogen level and the vulvar area begins to change from pink to a more red color and swells. For our research, the most important part of predicting estrus is the physiological changes like temperature. According to information I retrieved from the Pork Information Gateway, detection of estrus or standing heat is one of the most critical components of a successful swine breeding program. The widespread adoption of AI in the swine industry, and I'm not talking about artificial intelligence, but artificial insemination. Artificial insemination in the swine industry has shifted the responsibility of detecting estrus from boar to breeding technician. This is because estrus is the only period in which a sow is sexually receptive and capable of bearing a litter. Accurate and consistent detection of estrus is necessary to ensure insemination occurs near the time of ovulation and to identify open females. According to an article I read, artificial insemination is labor-intensive, time-consuming, and an economically important aspect of the production system. Vulvar skin temperature changes significantly during estrus in swine as determined by digital infrared thermography. Infrared thermography is the use of an infrared imaging and measurement camera to see and measure thermal energy emitted from an object. The group I have been labeling is Group 3. This group was recorded over a period of 10 days and the temperatures were captured 78 times. Infrared imaging will help us to determine whether a sow that is imaged is in estrus or not. According to the previous literature, there was a similar trend in sows with a peak vulvar skin temperature of 36.1 degrees Celsius. The gluteal skin temperature remained relatively steady. You may be asking yourself, what is machine learning? Machine learning is the art of programming computers so that they can learn from data. This slide shows the GUI, graphical user interface, that I interacted with. We have a previous and next button to navigate from photo to photo. I have a button to identify whether the photo I am looking at is either a vulva or an ear. I have a button to identify whether the sow is sitting, standing, or if the image is ambiguous, meaning that I am unable to determine the sow's position. And labeling the points of interest, which were the tip of the vulva and below the anus. When I insert the data, I can verify whether the data is collected accurately because it will return a value of true for all of the significant data points that have been identified. Throughout this process, I used multiple resources to complete the tasks I was given. The programming language used was Python. Visual Studio Code is the platform I used to run the Python code. GitLab is a collaboration tool so that we can update the files as needed and reclone the folders to keep up to date with each other's work. The last is the computer's terminal, which was crucial to getting started and downloading packages to run my programs through Visual Studio Code as well. Machine learning is an important component of the growing field of data science. Through the use of statistical methods, algorithms are trained to make classifications or predictions, uncovering key insights within swine breeding. Future steps are to complete labeling of the different groups to increase our data set, giving our program access to a much larger data set and allowing it to identify patterns in that data, all without being explicitly programmed. This will in turn allow our program to become smarter. We would also like to explore other machine learning techniques like classification, regression, and clustering for improved accuracy, because right now our accuracy has yielded a 73% detection rate. Our goal is to get more accurate predictions of sows and estrus, because this will increase the success of swine breeding programs and in turn reduce costs for farms by exploring many machine learning techniques. Right now, we are still in the input phase, but my mentor has developed a code to classify what I am inputting through the graphical user interface. This concludes my presentation. Thank you.